unless that printer-specific need is millions of liters a year. And we have some packaging folks that we are in specific applications for that we've developed specific inks for. So we develop inks for low, medium, and high viscosity. Most of what's happening in DTF now are Epsom-based. So you're running I-3200s or the XP600s. That's a low viscosity ink. So we design our ink for the viscosity. The next one is a medium viscosity ink. And for other digital printers in here, medium viscosity right now usually means you're using a Kyocera or a Panasonic head. And then the high viscosity. So the lower viscosity inks don't need much of a heat in the printhead or a sophisticated printhead to work. They're more like water, but as you move up into the viscosity and get a little bit thicker in the ink, you have a little bit more industrial robust head to push that ink out of there. We also look at surface tension ranges. You got to think about that ink coming out of the aperture. How is that ink going to hang in there? How is that ink going to, when it gets jetted, how is the drop going to form and reform and come back and hit the substrate and sit there as spread out? Printhead material capability. All of our inks that we release and that we publish a printhead for, we have gone through that manufacturer's kit for corrosiveness. So what we do if we're developing for an I-3200 is we call Epson and we say, we need your corrosive kit for our ink. They'll send a couple kits over. It's every part that's in that printhead. We'll take the ink and we'll soak it in those parts, or soak the parts in the ink, and let it sit there for a few months to see if any of those parts react to the ink. And if there's one of the parts is reacting, we'll go back to the lab, we'll say, well, we need to change the formulation, and it kind of starts the whole process over again, but it's some of the due diligence that we do in the ink for particular printheads. pH and operating temperature, again, the lower viscosities, they operate at a lower range, where the higher viscosity inks need a printhead with more of a robust heater in them to get them to jet. And then the application process. And if you start kind of looking at all these factors going into it, you're like, uh-oh, what if the viscosity is too high? What does that do to the rest of these things? So it's a bit of a mix and match and playing game till we get to a point where we know exactly what's going on. Here's my favorite slide that I've run into in my Dupont tenure. So this goes back to that thing, remember I described the bucket? If you put something in, what's going to come out of it? So the middle sections here are our formulation windows or our operating windows. So if you get outside of these windows, your printer is not going to jet that ink, or the color's not going to be correct, or something is not going to happen. So you can see what happens. Here, this is a good one, coloring in the ink. If we put more color in the ink, we're going to get a brighter, more optical density, right? It's going to be brighter in that color. But look what happens to the decap and the jetability. They start dropping, or they move out of that window. Same with the pigment to disbursement ratio. You can see what happens with the jetability, whether it goes up or down, and what happens to those three different factors. So again, we're looking at that operating window. And when we were developing our P600 DTF ink, we were using some thoughts from some previous inks, and we found that our operating window was too tight. So if you were really good on your DTF printer, you could calibrate really precisely, everything was just right, and you could print, everything was beautiful. But if one little factor slipped here or there, temperature, humidity, the film changed a little bit, it just fell off the rails and didn't work. So that led us to formulating a DTF specific ink. One of our core competencies is jetting. And in jetting, this is a big thing. This is how the drop comes out of the aperture of the printhead. We look at reliability. We look at time and time again how that drop is going to come out of the aperture. We look at drop velocity, how fast it's going to drop, how quick it decaps or how fast it can print, the throughput, how we'll see some videos later about satellite and drop volume characteristics of that ink, the frequency of response, latency, and page yield. Image quality and durability come down to optical density, how dark that ink is.
The drop size, the dry time. Dry time is very interesting in DTF compared to our other textile needs, because we're actually putting a water-based ink on top of a polyester film with an ink receptive coating. So that's kind of a big ask for a drop of water, because we want the drop to hit the film and spread a little bit and stay, but we don't want it to wick out. We don't want it to keep its exact shape when it drops. We want it to crash out on the film. Other things that go into this that we look at are drop velocity, again, drop placement. If one of the surface tension or the viscosity is wrong, you're not putting that drop down in the same place every time. So when you start dropping drops in places that are misfiring or mishitting, you start to change your color, or not to be able to get color, or things like graininess, smoothness get affected. And then we look at interbleed media, how the inks overlap with each other on the certain substrate that you're on. Got to think about DTF a little bit, is all the different kind of films out there. And if you've been around DTF a while, you've changed films, seen your films move left and right a little bit, and you know that some ink systems work best on certain films. So we look at that sort of thing too. That's where kind of that ink bleed and the drop comes down to. Some of the advancements made in digital pigment inks, and you notice I put pigment inks here because this pertains to DTG and DTF printing. So one of the biggest changes is in our previous technologies, we used titanium dioxide to make the white. As you can see, the size of the titanium dioxide is different sizes. And as that titanium dioxide sits, it falls out of suspension. We've all seen this. We've all used white ink. You know, you have to agitate your ink, you have to roll your ink. Some of you may have seen this on your printer. Some of you may have seen this in your lines, on your heads, your capping stations. But what's happening is, especially with our older technology, when it dropped down, you get this clumpiness look. In some of this clumpiness look, if it starts to do this, you can't get it back into suspension unless you really mix hard to mix it up. Anybody, probably the guys here, paint at the house, and every time you go back to that paint can, you're digging it off the bottom, getting it back into suspension. That's what you have to do, because the pigment in paint is so heavy it falls out of the vehicle. And it's even more so a little bit touchier in digital printing, because we have to put that really fine pigment through a really small hole to get it to come out of the aperture. So this technology was our first technology. It was probably 2004, 2005, all the way up to about 2021. This was the industry standard for DTG printing. So what we have with our new technology is, we looked at this and we said, we need to improve this. White cannot be sitting on the bottom of the bottle. If it does get there, how do we bring it back up? So we started looking at narrowing the size of distribution of our TiO2 pigments, so that none of them fell faster than the other one. So if you have a big pigment, it weighs more, it's going to start falling through that ink, and when it falls through that ink, it's going to start picking up the little ones, and on the bottom, you're going to get that cake that we call it. We used polymer dispersements, which are advancements off of our acrylic-based stuff that was used in the past. And again, the treatment of the TiO2 particles and the optical density and the redispersibility of that, and then coming up with a preparatory inkjet formulation to make this all work in the field. And I can give you an example here. This is previous technology. Come on. So on the right here is, or on your left, is what it looked like before. So you get the spoon, you put it in there, you can bring it up. You see how clumpy that is? And this is our new white technology. It's more syrupy, it's more, and both these samples were aged for the same time. There we go. So if you're looking at all this, you're thinking about what's happening on your printer, right? Which one would I rather have, the old technology or the new? I'm all for the new one. Oop, that might have been out. Another thing that we look for is we look at shelf life, what happens when that ink sits on the shelf. And some things that we measure here are viscosity. D50 is the whiteness point of the ink. pH, surface tension, conductivity. So this is 12 weeks of ink sitting on the shelf, and we go back every week and we read these things. You can see when this study stopped, we have over a year of data now that's not on this slide, but we want to put an ink out that's consistent, that once we make it and it ships to the user, the distributor, and before it gets packed out, we want that ink to be the same all the way through. At the end of the last presentation, somebody was asking about wash fastness and how many washes you get. On our DTG, we strive for an over 25 washes on a DTG print. And on the DTF, we strive for over 50 washes. I forget the guys that was in here was explaining that those 50 washes, it's not guaranteed. The printer and the decorator and the applicator still have to do their job of printing it correctly, curing it correctly on the printer, transferring it at the right times and temperatures, and that sort of thing. DTF, printing and inks. So some of you all came out of the screen printing industry. Some of you came out of the DTG industry. Some of you straight into DTF. Get out of the way. So what we did in this slide is we just tried to show the progression of apparel decoration from screen printing to DTF. Now, if you went straight into DTF, you didn't have to go through what some people might call pain of the other two processes out there. All these have pluses and minuses. This slide just shows how fast you can get to the first print with a DTF printer. We also formulate our inks for larger color gamuts. We print with blue, red, yellow, black. Some people refer to it as CMYK, but coming from a conventional print background, I can tell you that that blue is not cyan and that red is not the magenta, that all the standards of the CMYK color spaces are based on. So we can get a bigger color gamut than that. We can't get a full RGB color gamut. I've done some work with this ink, and out of 1,800 Pantone colors, I could match about 84% of them within a delta E of 3 or less, which is a pretty close match. Most of us that end up painting our walls in our houses can't see that difference because we're men, but our wives can pick up the little minute ones. And also this ink, we've done our product stewardship and sustainability. So we knew right out of the gate we had to make a non-hazardous product. So our P1600 ink is non-hazardous. We took the ethylene glycol out of the ink because for years we had brands talking about our DTG ink and taking the ethyl glycol out of it. And we had to take those out because those chemicals pop off California Prop 65 and the Washington State Child Protection Act. So if you're a DTF printer and you are striving for printing for bigger brands in companies that look for this type of thing, then your ink needs to reflect that. So here's the video. I hope this stays up. Jetting and reliability. So this is one of the coolest things that I think we have in our lab. It's called a drop watcher. So as we're formulating inks, this is an actual picture of the ink coming out of the print head. And you can see it comes out, it spits it out, it separates, then it comes back together. So that's kind of what we want to see. Sometimes during formulation, you look at one of these drop watch videos and it's like, it never comes back together and it starts to kind of explode, and that's a function of the surface tension and the viscosity of the ink. So you want a nice smooth drop here. And what this means is quick morning startups, low maintenance frequency during the runs, in batch-to-batch consistency. So what does this boil down to for the user with using Dupont P1600 DTF inks? So we've calculated there's about a 75% reduced downtime for the end user, which means with that 75% less downtime, you're printing 10% more designs, which means you're accelerating your growth rapidly because you're printing more designs. You're using an ink that the brands are looking for, so you're able to get more business that way. Less rework, and about 30% less ink usage to match existing systems that are out there. So when you start adding all this up, it's kind of interesting. I was talking to a user a couple weeks ago, and they have multiple machines. They were losing, out of their multiple machines, about 40 hours of machine time a day, just by stopping and cleaning during the day. So if you're stopping and cleaning 1 hour during your shift, think about that hour. Okay, you're losing the hour of the machine time. So maybe you're losing we'll just go $50. But you're also losing in that hour, if you're on a 2-head machine, maybe you're running 60 12x12s an hour. What's the cost of those 60 12x12s that you could have been running? I've heard anywhere from $3 to $8. Go with 5 to make it easy. So you lost another $300. So, using different inks, you have to look at all this and factor it into the total cost of ownership of the week, of the ink. What's this mean for OEM in distributors? Because I know we have some of those in the audience here. Well, if your customer is having more success on the printer running the ink, that means that you have more satisfied customers that will come back and keep buying the ink, but also you are spending less time on the phone talking to customers about ink issues. By the end of the year, you're having to warranty less heads for the year because the ink has been engineered to be consistent to run through that type of print head. So some key takeaways with this ink that we have on the market now, we have less downtime, which means more prints per hour. Reduced costs with equipment maintenance and post-sale support for the OEM and distributor side of it, and a brand focused on sustainability. That's about the end of it. Did I put everybody to sleep? Did you learn one thing? 2 things? 1 thing's good enough. Shelf life? So on the colors, shelf life it's a year from the time that we ship it. On the whites, for the new technology, it's a year. Yep.
Bulk or cartridge or?
No, it's bulk ink.
Okay.
So we look at cartridges. We work with people that openly promote us, and we work over the years with brands that it's kind of a sealed and shut case. So those brands may or may not cart it or do what they do with it, so it's.
So if I throw somewhere and it's relabeled, how do we know when it was shipped? There's no date on it.
It depends on who's relabeling it. So once we sell that ink and it goes to that third party, we've sold it to the third party. It's how they label it is up to them.
So can we buy direct from you, or how do we find distributors?
So if you come to me afterwards, I can give you a list of distributors.
Okay.
So if we buy ink and it does come in with like if it comes in and it's got an older date on it, is there a date at which you would say refuse that ink? If it's been sitting on a shelf and you get it and it's like, well, it's got shipped and it's 9 months old.
So in my experience, if it's 9 months old and you think you're going to use it within 3 months, go for it.
Okay.
If ink comes in and it's over a year old, I wouldn't use it.
Okay.
And that's, personally for me, from being a printer in my past lives, that's how I'd treat any ink almost. So things when ink starts going bad, things start going really bad. I mean, I've had to deal with some horror stories that are just, personally when I was running my shops and things like that you're just like, what is going on here? Then it usually comes down to something like that.
What
You're
happens
next.
to the ink when it is over a year old? Like what would we experience with the printer?
You may notice color change on the colors, print to print. That's a fun one to chase. Hey, why is this color on this print? And I'd make the change and I come back and it's a different color because I made the change that I don't like. So I go back to the original color and it's not that color again. That's usually what happens on the white prints, or the colored ink. The white prints, you'll start to see some of that settling.
You said there were a lot of variables with regards to film. So if I were to switch from one film to another, from like matte to, let's say, a glitter, how does that affect the ink and how it lands and
So if you change films and you run the calibration you have for your last film, and it looks like it's working, you're probably safe. When you need to recalibrate, you'll definitely see a difference on the film. The ink might not set up, it might model, might run. So if anytime you're changing films, you just have to run a test.
Just as a follow-up, how do I recalibrate? Or what is it that I'm recalibrating?
So when you calibrate a printer, you're setting up how much ink you can put down on the film. You're setting up your color curves, how much of each color you can put on there. You're setting up total ink limit. And then you're actually going and setting up a new ICC profile so that different films will give you a different color yield. So you have to go back and reset up the ICC profile. Now, a lot of people that I've seen try to do this because a lot of the printers I see out there have digital front ends. They try to do it on the printer. That's not the place for it. The place for that is to do it is on the RIP or in the file coming into the system. So, for example, I've seen people want less white, so they go in and they restrict the print head, which is kind of like putting your fire hose on half. You want to have that print head firing as much as you can, and you want to have the white restricted before it gets to the printer. Coming to you next.
It's kind of a follow-up to that. So when you're testing your inks, I'm assuming you're testing on specific films, and then do you publish that, like this ink was certified for this film, so on and so forth? Or?
Yes and no. So we try to get our hands on every film out there.
Okay.
So we know what they work on and what they don't. The film suppliers and manufacturers will come to us to develop coatings for it. They're also doing that across the board with other ink manufacturers. So we know the ones that it's working on. We don't do a published list of it, though.
Okay, fair enough.
So with you being a inks manufacturer, for a supplier or operator, would it be, are there specific models or not models, are there specific printers that you suggest as far as the capabilities that goes best with your type of ink?
No, because we formulate to the print head,
Got it.
not the printer.
Okay.
There are some like just basic things you can do, like have a good rip, have access to your calibration, learn how to use it.
Okay.
Learn how to put a file in and what file types are coming in. After a few months, maybe years of printing, you'll start to look at film and see how ink is crashing on it. But no, we don't develop to the printer, that we develop to the print head.
Okay.
So let's say we're running some Chinese ink right now and we wanted to switch. What would be your recommendation for switching that in an existing machine?
On how to switch the machine out?
Right, like do we run it as low as we can? Do we run cleaning? I mean, you can give us the.
So if you're new at digital printing, switching that printer out the first time is a very daunting task. I've had a lot of new printers in my life and it's like, oh, I gotta switch the ink. But once you figure out it's just like switching the ink, the oil in your car, there's a process. Drain the ink out, get it out of the system, put in some DI water, wash your bottles out, run it through the system, take that out, put in your ink manufacturer's flush because it's matched to the ink, put that in, and then after that you don't have to flush the system, just the bottles, pour the ink in and follow the flush with the ink. And it's the first time you do it, you're like, oh, it's a daunting task, but once you do it a few times, it's fairly easy.
A couple hours, you think?
45 minutes,
Oh.
hour. In the back.
So currently, we're using the wide format that DTF Superstore supplies, and their wide format ink is recyclable. Because the print heads stay separate, the white goes down into a bottle, and then we can then take that and put it back into the top 3 use. Is your ink the same?
No, well, we're not on any systems like that I know of.
Okay.
So what I would say with that is, if an ink is coming through a print head, and it's coming through all those small apertures, it's coming through some shear forces and some things that, with the ink, I don't know how many times you could force it back around before it would start changing the fresh ink that's coming into the system.
So I'd have to try it.
Try it, yeah. Let me know how it goes.
Thank you.
Any other questions?
Nothing? Oh, that was, no chemistry questions.
Now's your chance
Yes.
for Scott to say, I don't know. Great, thank you, Scott. I'm checking this mic to see if it's working any better than usual. But great, thank you, Scott, so much.